Motion. This lesson is about Class 9 Cbse Physics. Chapter 8 Motion. Presented by Sparkling Bookworm. Rate of change of velocity. During uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of the object for any time interval is zero. However, in non-uniform motion, velocity varies with time. It has different values at different instants and at different points of the path. Thus, the change in velocity of the object during any time interval is not zero. Acceleration. The velocity of an object changes from an initial value u to the final value v in time t. The acceleration is acceleration. The acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. The SI unit of acceleration is ms-2. Acceleration. For example, if a car traveling along a straight road increases its speed by unequal amounts, in equal intervals of time, then the car is said to be moving with non-uniform acceleration. Activity. In your everyday life you come across a range of motions in which a. Acceleration is in the direction of motion. b. Acceleration is against the direction of motion. c. Acceleration is uniform. d. Acceleration is non-uniform. Can you identify one example each for the above type of motion? Activity. In your everyday life you come across a range of motions in which a. Acceleration is in the direction of motion. b. Acceleration is against the direction of motion. c. Acceleration is uniform. d. Acceleration is non-uniform. Example. Starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters s-1 in 30 s. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters s-1. In the next 5 s, calculate the acceleration of the bicycle in both the cases. Solution. In the first case, initial velocity, u equals 0. Final velocity, v equal to 6 meters second minus 1. Time, t equals 30 second. From equation, we have solution. Substituting the given values of u, v and t in the above equation, we get a sad smiley 6 meters second minus 1 minus 0 meters second minus 1 by 30 second equal to 0.2 meters second minus 2. In the second case, initial velocity, u equal to 6 meters second minus 1. Final velocity, v equal to 4 meters second minus 1. Time, t equals 5 second. Solution. Then, a sad smiley 4 meters second minus 1 minus 6 meters second minus 1, /5 second equals 0.4 meters second minus 2. The acceleration of the bicycle in the first case is 0.2 meters second minus 2. And in the second case, it is 0.4 meters second minus 2. Question. When will you say a body is in I. Uniform acceleration. 2. Non-uniform acceleration. I. A body is said to be in uniform acceleration if it travels in a straight line, and its velocity increases or decreases by equal amounts in equal time intervals. 2. A body is said to be in non-uniform acceleration if the rate of change of its velocity is not constant. That is differs in different time intervals. Question. A bus decreases its speed from 80 km/h-1 to 60 km/h-1 in 5 seconds. Find the acceleration of the bus. Question. A train starting from a railway station and moving with uniform acceleration attains a speed 40 km/h-1 in 10 minutes. Find its acceleration. Problem. A car starts from a full top and in 20 seconds is traveling 10 m per second. What is the acceleration? Solution. The formula for acceleration equals A equals Vf minus V0 by T. So A equals 10 meters by second minus 0 meters by second by 20 second equal to 0.5 meters by second 2. Problem. A motorcycle traveling 90 miles per hour accelerates to pass a truck. 5 seconds later the car is going 120 miles per hour. Calculate the acceleration. Solution. The formula for acceleration equals A equals Vf minus V0 by T. So A equals 120 minus 90 by 5 second equal to 6 miles per hour by second. Problem. A rocket releases a satellite into orbit around Earth. The satellite travels at 2000 meters per second in 25 seconds. What is the acceleration? Solution. The formula for acceleration equals A equals Vf minus V0 by T. So A equals 2000 minus 0 by 25 second equal to 80 meters by second squared. Problem. A soccer ball is kicked and travels at a velocity of 12 miles per second. After 60 seconds, it comes to a stop. What is the acceleration? Solution. The formula for acceleration equals A equals Vf minus V0 by T. So A equals 0 minus 12 by 60 second equal to minus 0.2 meters by second squared. Graphical representation of motion. Graphs provide a convenient method to present basic information about a variety of events. For example, in the telecast of a one-day cricket match, vertical bar graphs show the run rate of a team in each over. To describe the motion of an object, we can use line graphs. In this case, line graphs show dependence of one physical quantity, such as distance or velocity, on another quantity, such as time. The distance-time graph for uniform motion. Consider the table which shows the distance walked by a person at different times. A graph is drawn by taking time along x-axis and distance along y-axis. The graph is known as distance minus time graph. The distance-time graph for uniform motion. A graph is drawn by taking time along x-axis and distance along y-axis. The graph is known as distance minus time graph. Speed equals distance covered by time taken. Equals slope of the straight line. Equals Cbse by account, from the graph. Equals 500 by 5. equal to 100 meters per might use. Distance time graphs. The change in the position of an object with time can be represented on the distance time graph, adopting a convenient scale of choice. In this graph, time is taken along the x-axis, and distance is taken along the y-axis. Distance time graphs can be employed under various conditions, where objects move with uniform speed, non-uniform speed, remain at rest, etc. Distance time graphs. We can use the distance time graph to determine the speed of an object. To do so, consider a small part AB of the distance time graph shown in Fig. Draw a line parallel to the x-axis from point A and another line parallel to the y-axis from point B. These two lines meet each other at point C to form a triangle ABC. Now, on the graph, a count denotes the time interval, t2 minus t1, while BC corresponds to the distance, s2 minus s1. We can see from the graph that as the object moves from the point A to B, it covers a distance, s2 minus s1, in time, t2 minus t1. The speed, v of the object, therefore can be represented as v equals, s2 minus s1, by, t2 minus t1. Comparison of speed. At the distance time graphs of three different people, Asha walking, Safira cycling and Kaishka going in a car, along the same path in Fig. We know that cycling can be faster than walking and a car can go faster than a cycle. The distance time graph of the three would be as given in the following graph. The slope of the line on the distance time graph becomes steeper and steeper as the speed increases. The distance time graph for non-uniform motion. We can also plot the distance time graph for accelerated motion, non-uniform motion. Table shows the distance traveled by a car in a time interval of 2 seconds. The distance time graph for non-uniform motion. If we plot a graph between the distance traveled and the time taken, it would be as shown in figure. Note that the graph is not a straight line as we got in the case of uniform motion. This nature of the graph shows non-linear variation of the distance traveled by the car with time. Thus, the graph represents motion with non-uniform speed. Distance time graph for a car moving with non-uniform speed. We can also plot the distance time graph for accelerated motion. Table shows the distance traveled by a car in a time interval of 2 seconds. Velocity time graphs. The variation in velocity with time for an object moving in a straight line can be represented by a velocity time graph. In this graph, time is represented along the x-axis and the velocity is represented along the y-axis. If the object moves at uniform velocity, the height of its velocity time graph will not change with time figure. It will be a straight line parallel to the x-axis. Figure shows the velocity time graph for a car moving with uniform velocity of 40 km/h-1. Velocity time graphs. To know the distance moved by the car between time t1 and t2 using figure, draw perpendiculars from the points corresponding to the time t1 and t2 on the graph. The velocity of 40 km/h-1 is represented by the height account or BD, and the time t2 minus t1, is represented by the length AB. So, the distance s moved by the car in time, t2 minus t1, can be expressed as s equals a count CD equals 40 km/h minus 1 into t2 minus t1 h equals 40 t2 minus t1 kilometers equals area of the rectangle ABDC, shaded in figure. Velocity of a car at regular instants of time. Consider a car being driven along a straight road for testing its engine. Suppose a person sitting next to the driver records its velocity after every 5 seconds by noting the reading of the speedometer of the car. The velocity of the car, in km/h minus 1 as well as in m/second minus 1, at different instants of time is shown in table. Velocity of a car at regular instants of time. If the car would have been moving with uniform velocity, the distance traveled by it would be represented by the area ABCD under the graph. Since the magnitude of the velocity of the car is changing due to acceleration, the distance s traveled by the car will be given by the area ABCD under the velocity time graph. That is, s equals area ABCD equals area of the rectangle ABCD plus area of the triangle ADE equals AB into BC plus half AD into D. In the case of non-uniformly accelerated motion, velocity time graphs can have any shape. Velocity of a car at regular instants of time. Fig. A shows a velocity time graph that represents the motion of an object whose velocity is decreasing with time, while Fig. B shows the velocity time graph representing the non-uniform variation of velocity of the object with time. Activity. The times of arrival and departure of a train at 3 stations A, B and C and the distance of stations B and C from station A are given in table. Plot and interpret the distance time graph for the train assuming that its motion between any 2 stations is uniform. Activity. Distance covered from A to B 120 minus 0 equal to 120 kilometers. Time equals 11. 15 minus 8 15 equals 3 hours. Average speed equals 120 by 3 equal to 40 km by hour. Distance covered from B to C 180 minus 120 equal to 60 km. Time equals 13:00 minus 11:30 equals 1.5 hours. Average speed equals 60 by 1.5 equal to 40 km per hour. Question. What is the nature of the distance time graphs for uniform and non-uniform motion of an object? When the motion is uniform, the distance time graph is a straight line with a slope. When the motion is non-uniform, the distance time graph is not a straight line. It can be any kind of curve. Question. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? If distance time graph is a straight line parallel to the time axis, the body is said to be at rest. Question. What can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? If speed time graph is a straight line parallel to the time axis, the object is said to be moving uniformly. Question. What is the quantity which is measured by the area occupied below the velocity time graph? The area under the velocity time graph gives the distance covered by an object. Thank you. Please share, like and subscribe the channel.